This is just a quick video to give you an introduction to what you'll have to do for task 3 and how to set up the code and get started. You only have 3 questions you have to work on this time. The first one is a very small program with small modifications where you have to go in and add a new feature to it. This is practice to get you creating your own comparator and then giving it to a piece of code that needs to use it. Question 2 is here to give you practice with setting up a generic class and then using a comparator as part of it. So you are given a class that right now is not generic, it's tied into one type, and then you have to convert it into a generic class, which will require you using a comparator. And both of these things are needed as practice before you go on to the bigger question. What we've been working on is building your own linked list data structure. So your first basic training wheels data structure of a linear data structure for holding data that will then grow. And this will be a doubly linked list that has some special methods within it. You have an entire class structure that's already been given to you, and you have a set of what's called Junit Tests. These are built-in Java tests that I have written that will automatically run and test each one of your actual methods to validate if you have implemented them properly or not. And I'll be using this as part of the testing phase. So I will run those tests, see what I get back, and then also go in and check and validate your code itself for that structure. Now to get started with, you will see that when you download it that you will have 3 separate directories of actual code. I suggest you set up 3 different actual projects, so independently for each question to keep things organized, since these are 3 separate different programs. And all you need to start doing is going into each one of those directories, like question 1 here, highlight all the code, drag and drop it onto the source folder for your project, make sure it's selected copy, then click OK. And you can see from question 1 here that you have a basic system that's already set up for you. That's basically like all it is really is given a list of actual student objects, information. So it's in an array list right now, right there. And then all it does is that it's going to sort it based upon a certain feature of that class and then list it out. And that's all that the main run method does for now. The loading the data is just hard-coded since this is a small example. And the sorting here is not something you have to implement. It's actually done by a built-in class and method that's in the Java library. So it's in the collections class and it's called the sort method. So it'll organize it. And what it takes is some kind of actual collection, so in this case an array list, and then the way that it should actually compare to sort them, so the actual comparators. And so this is where you'll have to make your own comparator to add to it. And all you're going to have to do is that right now it's doing it by name and ID. You'll have to modify this program to actually sort by age. And you can see the examples here of how it's doing it now, making a comparator, so of type student, and a specific name, and this comparator here just compares the names versus this one that compares the actual like IDs. And just to show you that, and since not all the code is done in here, I've also tried to make the actual student object itself self-governing, so the actual comparison methods are in here as well. They're then called by the comparator. Boom. So all things that you should look at to see how you change. And it's just really getting used to like, how do I create my own comparator? How do I set it up? And how do I give it to another piece of code that then is going to use it? So task 2, or so question 2 of task 3. There are just 2 small classes in here. Drag them again onto the source, copy files. So I said here again, your goal here is to convert the node and node main properly now to make this a generic class. So again, the generic class set is what we've covered in the Java new and old, where you're having the type parameters you're passing in like we've seen before up here. So basically creating your own equivalent of what an array list allows you to do by defining the types later on. So what you would take is that by the end this must function completely fine, but you are making sure that here for this instance variable, this becomes dynamic type that comes in, And then for this array list, this is the matching thing again as well, that it's going to hold the same type that this will be. And you must now go through the rest of this actual class, modifying it. Most of it's going to be very quick changes, but you're going to have a bigger step here on the Boolean is same method, where it's passing in another node to actually compare to. In this case, since we're going to be going to generic when comparing the data, we don't know it's int anymore, we're going to need where it's going to have to accept a comparator that'll be of the same generic type that was passed in as a parameter for the generics at the top, and then using it to do the rest of these actual comparisons. And what you may notice is that in here is that we have data set to private, and down here we are getting another object of type node, and we're bypassing that encapsulation. Is just be aware in Java it is legal that when you're inside the node class, if you're working with another object of type node, it's perfectly valid to bypass encapsulation, so you can keep things hidden. So you can see it going through here just to validate first if we have the data being the same, and then now it's next going through comparing the two array lists that are in each object to validate that they are the same size and that at each location they also contain the same data that is from here, combining down to the end result for what it will return coming back. So you need to modify and turn that into a generic class, and then you need to make sure then that the main is properly updated to show an example of working with it. And this here also shows that you can see if everything's working right, because they're combinations of if they're the same, showing you what you'd expect and making sure that you got everything working properly. So another small one, but for practice, if you want to review, go back to the actual Java new and old video, and you'll see examples of me converting a class that's not generic into one that is generic and using comparators. And then in future tutorials, we will also go over examples of doing this with the assignment. Now, the bigger question from all of this is now then the actual question 3, which is your larger doubly linked list that you need to convert over, and this has JUnit tests. Now, we're going to have to start by adding the code the same way we've done the previous 2 questions, but we need to do an extra step of adding JUnit to the build path. So this video here is just going to demonstrate it for doing it for Eclipse. If you are currently using IntelliJ, you'll have to look up how you add JUnit to your project, or it may just be set up that it's properly working already. So first off, just make sure you copy all the code you see here, even these directories. You need to preserve the package structure and drag and drop this onto the source folder. Make sure again it says copy files and folders. You first copy it over here, it's going to say that there's errors in the D list for the D-linked list package in the test. This is because of the actual build path. What you need to do is first click on just right here your actual project name, go right mouse click, and then go down to select build path. And then from here you want to select add libraries. Once I've selected that, it should bring you to this window, and we can select that. See, JUnit is already selected here. We can click on it, just leave whatever default versions here, go finish, and then we see that everything has disappeared. Errors, and we are ready to go. Just closing the previous code. Now, if we go into all of these, is that the structure is that up in the default package, you will see some example programs that are then instantiating a generic doubly linked list with a certain type and calling some of the methods that are already in it. And see another example, or then it's using the actual string, so seeing how we can use the same class and store different data types. And you have the example of then using a comparator, so one that you're given, to actually do some comparisons between things. So how to compare. Remembering that you can see the minus, like negative, 0, and 1 values that it gives back depending on how it's actually compared. Within the comparison objects are some default comparators that have already been set up that can be used then for comparison when you're instantiating with different types. And now we have our D-linked list class. And within all of this, the only class that you need to make changes in here is the D-linked list class. The D-linked list iterator is already written. It's one that steps through a linked list. You will be not using this inside the linked list class. This is just used for externally from right here. You have a node class that's already been written for you. You can add small things to it if you want, but you shouldn't really have to add anything to it from here. And then you have the JUnit tests that have been written by me that go through testing your entire program. So if we open up dlink list, you'll see the beginning structure of what you're working with. So the start and end, because this will be a doubly linked list where you need to always keep a reference to the start and to the end of the actual list. The constructor's written for you to make sure it's null in the beginning. And then you have a whole bunch of other functions that describe what you need to do. And you need to make sure that these are done efficiently. So right now there's comments saying that you need to implement things. There's things just to make sure it's compile. You need to follow saying what it says above and following the Java doc below for saying for the actual returning of everything and what the functions are supposed to do. Things like this, and tell you do not change and leave this. This is part of the testing you use for other things. But then you've got the rest of what you need to do for things of like adding to the front, adding to the end, adding a sorted. So given a piece of data, it adds it into the current list that you have in a sorted order. The get method, so given an index, returning back data. And be aware of this one, it has a special catch that if this index is out of bounds, you need to throw an exception to properly deal with this. You have a remove at a specific location, which will then also throw an exception if the index is out of bounds. And then you have a contains method that returns true if the actual object is currently found inside. You have a print method currently right now that you don't need to do anything else. That will just go from the start to the end, currently printing out the actual data that's inside of each object or each node you have within your list. So your goal here is to implement all those methods in the very beginning and making sure that everything works properly. And as you add them, you can then run the actual tests. To run the tests, you select the test dlink list class right there and click run. This will then kick in the JUnit system, which will bring up a different one, and it'll go through running each test in that class one by one. And what you'll see is that you'll have 19 runs. Right here is for each one, and it tells you how many failures there are. Your goal is to get that there are actually 0 failures, that this is passing all of them. And you can see it's all red for right now. You can see the X's through everything else that's in here. That means that all of these individual tests actually failed. And so your goal is to get so this entire bar is green, you have 0 failures, and you've gone to pass. Now, getting these to pass all of the tests doesn't guarantee that you'll get 100% on this part. It just means that you pass the test, and so far it looks like you have everything working properly. And then next, I will go in and validate you've actually done the code properly. Now, when you look at the actual testing class, the way JUnit is set up is that each of these methods is doing one specific test, and there's really long names. And so these are basically descriptive of what it's testing. Things like remove at, not empty, check. So removing at a location where the list is not empty. You can even then go in and click on those methods. You can just see I double click on one of them, and it's going through and showing you, okay, well, here's the actual testing code that's in here, and seeing the steps of things like, hey, the elements it has, then seeing the elements it removes, and going through everything and validating that everything has been done properly. Okay, so your next goal from here, if you're watching this video, is to get started and get this done for the 29th. We have the midterm coming up long after that, so I may allow extensions, but they will not be that long. And if you take too long with the extension before the midterm, you may not be guaranteed to actually have any feedback on the assignment before the day of the actual midterm due to time constraints for me marking and you handing things in. And stuff from this assignment will come on the actual midterm itself. So basics may not be the most hardcore questions, but it'll be very important that you start this assignment early. This is not one that you should be leaving to the very last day to start. There's a lot more that goes into this. So I'm going to require that everyone start this a lot earlier. Other than that, go on and continue being the great people that I know you are.